Dude. Welcome to my science presentationist.
We're not using that line.
Wait, what?
Retake that. Hit me with another one.
I feel you. Welcome to Carson's Super Technic Fantastically Awesome Science World. World. Professor Newcon Carson Ponda Newfong Honda Civic Teriyaki Chicken the second here, and I'm about to explain to you what science is all about. I can't do science in this boring lab, so I have to transition myself with science. Bring it up. Yeah.
One long walk later.
Oh, hey there. Welcome to my lab. Since we had to transition from the other lab with science, we had to go to my new laboratory. That's not really a lab at all. It's actually my room. Nor this is a lab coat. This is a coat. But that's besides the point. We're here to talk about science. Basic stuff. Like compound. What is a compound? A compound is a substance that is composed of two or more different atoms bonded together. Isn't that rad? We see compounds in our everyday life, both created naturally, like air, and artificially, like Coke, that you drink. I think. I hope. Maybe. But for example, besides Coke, water. Water is a binary compound. It's a thing that we drink to keep ourselves alive in this science world. And there are 4 distinct types of bonds, such as binary, polyatomic, transitional, and hydrates. We'll scuba dive a bit deeper into these, starting with binary. Binary bonds are actually the simplest concepts to follow, actually. Pretty much it's just a non-metal and a metal together. And the rules are pretty easy to follow. A baby could do it. That's not a baby. Now we're getting to binary, as we saw in the definition. So, binary only uses the column 1, 2 to 13 through 17. As you can tell from above, there's different charges. That's cool. And also, we don't use 3 to 12 because that's for transitional. We'll save that one for later. Now let's get to naming.
All you have to do for changing the name for binary is basically reversing the entire situation. So basically just trying to just reverse it, going backwards. But the only thing that you're doing is like the charges are kind of gone, and all you have to do for the ending of the second non-metal is changing the ending for, so like sodium oxygen, all you have to do is change the ending, so it'll be sodium oxide because it's a binary.
Welcome to the Madami today. I'll be the demonstrator for the science. My name is Kambang Jantapandit Sayavang Putaivang the first, with my assistant Walter. Oh my god. Now let's get to polyatomic. Polyatomic is a little bit more complicated than binary, but it follows the same concept. Basically, it's a metal, bonded together with an already existing compound. I'll just show you how it's done. Now we get to the polyatomic, the big boy stuff, better than binary. Poly meaning many, and for the example we use calcium and carbonate. How you do the same thing? The same thing with the X, same thing. Put the power right here, calcium is 2. Carbonate, -2, same thing, see? You do the X, same thing, right? Put the metal first all the time because it's strong like the boy, I tell you already. Put the C, A, and you bring the 2 right here, right here. Put the parenthesis right here, see that? Right there, Put the 3 right there. Put the 2. So it's the same thing, simplify all the time. Right here, so do like this, do like this. Put the red right here. Boom.
For changing the name of polyatomic, all you have to do is still the same process, kind of the reverse action, and Now the true difference now is changing the ending again. So you're changing the ending to "ide" now still, but since it's this is magnesium hydroxide, it's hydrogen and oxygen combined together, since it's not part of the periodic table. We just changed still the ending to "ide" because polyatomic bonds are cool. Yep.
Transitional bond now is pretty similar to binary, as it still uses metals, but now the only difference is that you use 3 through 12 as the metals. And
Oh, hello. We have my partner in crime, Will Smith. Right here. Do the work. He already died today. Now, because we go to the transitional part. Transitional, we have for the example, cobalt and sulfur. We have the metal and non-metal already, right there. See? The only difference today, we have the Roman numeral, the hard part today. Not a lot of people know what that means. But we still have the same basic, the X, the cross right here, where we change the number right here, the charge. So sulfur, have the -2 right here, yep, right there. Cobalt already have the charge for you, right there, number 3, right there. You do the cross all the time, right here. Cross. Put the metal first all the time, because it's a rock. The Wayne Rock Johnson. You put the C, the O, bring the -2, bring it to a 2 today. Bring sulfur down, put that for the S, and put a 3 right there, man. See that? Then you put a rhyme, another rhyme, more rhyme. Perfect.
For naming transitionals is basically the same process as changing it for binary, reversing the entire action and showing the change at the end of the non-metal. So like for nitrogen that is shown here, we just changed the ending from nitrogen to nitrate, changing the 8 and removing the ogen, I guess. And for nickel, we put it back and actually showed the charges by using the Roman numerals. So that's it.
now for our last example, it's being as simple as the rest. Hydrate. All it has is that it includes water in it, because, no, that's the reason for its name. Hydrate. Really good water. Really good water. And all that's different is just changing the name of it. Isn't that easy?
Now we get to the final one. The final countdown. We do the hydrates. It's the hydrate in the ionic bond have the ocean in it, meaning the water. So we're gonna do the bond prefix and the hydrate. But first let me tell you about we put the 1, 2, 3 it's the mother. Die, try, tetra. The same thing right there for the name part right there. So we're gonna do that for the prefix. So we're gonna use the bond. Use the bond. Cow. Freum. Surfato. Right there. English is not my forte. Then we get to the prefix for hexa for the number 6. And for hydrate, it's the same thing. Same thing all the time. Can be hydrate. For formula, easy, all the time. Same thing right here. You put the Ca, you put the sulfate part right here. Oh, right there, X right there. For symbol, it's a dot for multiply. And for 6, you go for 6 hexa water. 2O. Right, good.